Good day, Nortonistas! Welcome to our week 5 of quarter 4 of grade 10 science. Only here at Science Matters, where learning never stops. And so for our most essential learning competency is to apply the principles of conservation of mass to chemical reaction. But before we talk about the conservation of mass, we will be talking about first chemical reaction. So what is chemical reaction?
Chemical reaction is a process in which one or more substances, which we call reactants, are converted to one or more different substances, which are called products.
Chemical reaction is everywhere. It happens every day and everywhere around us, even inside our bodies. But how do we know that chemical reaction really took place? Or how can we say that chemical reaction really took place? Of course, there are evidences for which we can tell that chemical reaction really took place. And what are these evidences? We will find out with these experiments. And so our topic for today is the different types of chemical reaction and the different evidences of chemical reaction. Alright, so first things first. Since we will be dealing with chemical reactions, so definitely we will be handling chemicals. And so precautionary measures are needed. First, we will be wearing our lab gown. Okay. There. And of course, let's tie our hair. Here it is. Some of the materials needs to be prepared first before we perform our experiments. And two of these are the 10% copper sulfate solution and the 10% sodium hydroxide solution. So as you can see, these chemicals are both in solid form, so we need to prepare this first to make it a solution. To create 10% copper sulfate solution and 10% sodium hydroxide solution, we will be doing the same procedure. First, we will be using a pocket scale where we can measure 10 grams of each of the following. In making these solutions, of course, we will be scooping our chemicals from our containers. So in scooping the copper sulfate powder, so we will be using one spatula, and a different spatula will be used in scooping sodium hydroxide lime. We need to use different spatulas, okay, so that one will not be contaminated by the other. Measure 10 grams of the copper sulfate and put it here. We will now be pouring here in our graduated cylinder distilled water up to 100 ml. 10 grams of our copper sulfate plus 100 ml of distilled water, that will be our 10% copper sulfate solution. And the same goes with the sodium hydroxide solution. We will be measuring 10 grams of this using our pocket scale or our weighing scale, and then 100 ml of distilled water once again, and that will be our 10% sodium hydroxide solution. But be very careful in handling these chemicals. Do not touch them with your bare hands, okay? Alright, so for our first experiment, it is entitled Iron Nail Copper Sulfate Reaction. Alright, so we will be needing iron nails. There. Alright. And of course, the solution that we have prepared a while ago, the 10% copper sulfate solution. And also we will be needing test tubes and test tube rock. So for our procedure, we will be filling one of our test tubes with 10 ml copper sulfate solution. So here it is now. And then one nail will be placed here in one of our test tube. Okay. And the other nail, we will be placing it here in one of our test tubes. Okay, like that. And so we will be observing the two later on. So it's the result of our first experiment. Here. So the iron nail looks like this, and the iron nail submerged into a 10% copper sulfate solution. Looks like this. Okay, so that's it. So for our second experiment, we will be doing a magnesium ribbon reaction experiment. For our materials, we will be needing, alright, so this is our magnesium ribbon. To cut the ribbon, of course, we will be needing the scissors. To hold the ribbon later on fire, we will be using this tongs. We'll be using the alcohol lamp with the denatured alcohol inside. Of course, we will be very much careful with this. And our matches. Alright, so for our procedure, we will be cutting at least 10 cm of this magnesium ribbon. Alright, we will be lighting now our alcohol lamp. We will be wearing goggles for this activity. Okay, so let's wear our goggles now. Let us now put it here and put it on fire. So let us place hold our magnesium ribbon and flame like this. And wait for its reaction. There. So as you can see, alright, that's it. Okay, alright, so try to look at our final product. What happened to our magnesium ribbon? It turned to a very white, soft, in powder form, white thing. And also, as you have observed, when we expose it in fire, it glow or it light as if it's a firework. So for our third experiment, it is entitled the hydrogen peroxide or the agua oxinada reaction. So of course, for our materials, we will be needing the hydrogen peroxide or the agua oxinada. We also be needing the manganese dioxide. There. So for our procedure, we will be measuring 20 ml of this, and to do that, we will be pouring this here in our graduated cylinder, which measures 10 ml. Two of this graduated cylinders, so to make it 20 ml of the hydrogen peroxide or the agua oxinada. And then pour it in a beaker, and then we will be adding a few drops of manganese dioxide in here. So after combining the two later on, the hydrogen peroxide and the manganese dioxide, we will now be lighting our match and place it near the bubbles that will be formed at the top of our solution. And we will be observing the reaction of the fire and the solution later on. Alright? So for our fourth experiment, it is entitled Vinegar and Baking Soda Reaction. The materials that we will be needing are the following. So of course, we will be needing our vinegar and baking soda, laboratory thermometer, and of course a beaker. So for the procedure, all we need to do is to pour 20 ml of vinegar here in our beaker. Then we will be getting the temperature of the vinegar, okay, using our thermometer. And then afterwards, we will be adding 1 tablespoon of the baking soda here in our vinegar and the beaker. And observe what will happen, and of course, get the temperature using the thermometer. So let's do this. Alright, so for our fifth and last experiment, it is entitled Copper Sulfate and Sodium Hydroxide Reaction. So we will be needing the 10% copper sulfate solution which we have prepared a while ago, and also the 10% sodium hydroxide solution which we have prepared also a while ago. And also, we will be pouring these solutions in test tube, combining the two, and we will observe what will happen. So let's do this. Alright, so as you can observe, the combination of the 10% copper sulfate solution and the 10% sodium hydroxide solution results to this. It's like a gel thing, okay, inside the test tube. So as you can see, there is a formation of precipitate. Alright, so to conclude and to recap all the experiments that we had, let's discuss one by one. So for the first experiment, we had the iron nail and copper sulfate reaction. So it is Fe plus CuSO4, and so it yields to FeSO4 plus Cu. Therefore, we can conclude that it is a single displacement reaction. And for the evidence of the chemical reaction, we have observed that there is a change in intrinsic property because the iron nail changed in color and also it changed in texture. Also, the copper sulfate solution changed from the color blue to green. So those are our evidences of the chemical reaction between the iron nail and the copper sulfate solution. Alright, so for the second one, we have the magnesium ribbon reaction. So magnesium is Mg, and since we place the magnesium ribbon over the flame, so there is the presence of oxygen, and so Mg plus O2, or the oxygen molecule, yields to magnesium oxide. So for the type of reaction, we could say that it is a combustion reaction or a combination reaction. And the evidence for the chemical reaction, we could say that there is a production of energy in the form of light, and also there is change in intrinsic property because the magnesium ribbon, which is originally a silver metal, turned to white and turned to powdery form. Alright, so those are the evidences that there is a chemical reaction in the magnesium ribbon reaction. Alright, so for the third one, we had the hydrogen peroxide or the agua oxinada reaction. And so therefore, H2O2 yields to H2O or water plus the oxygen molecule. And so we could say that there is a decomposition reaction. So the oxygen molecule O2 is removed from the H2O2. Therefore, that is what we call a decomposition reaction. The evidences for the chemical reaction on this experiment are the evolution of gas, because as you can see, as we poured the manganese dioxide onto our agua oxinada, there were bubbles at the top of the solution. And there is also a change in temperature because you will touch it, you will feel that it turned hot. How can we prove that the oxygen molecule was removed from hydrogen peroxide, H2O2? First, because of the bubbles that were seen at the surface of the solution. And how did we know that these bubbles are actually oxygen? When we put the light match at the top of our solution, as you can see, the flame in the match grew even more. So we could say that the bubbles there is actually oxygen. Okay? And so for our fourth experiment, it is the vinegar baking soda reaction. and it is an acid-base reaction because vinegar is a weak acid and baking soda is a base. And this acid-base reaction will lead into the formation of salt and water. How do we know the evidences of this reaction? Of course, as you can see, there are bubbles at the top of our solution. So therefore, there is an evolution of gas. And what type of gas is that? Of course, carbon dioxide. And we have also observed that there is a change in temperature. When there's only vinegar in the beaker, the temperature reading was 30 degrees Celsius, while after pouring the baking soda onto our vinegar and we checked the temperature reading was 26 degrees Celsius. So that is an evidence that there is a chemical reaction between vinegar and baking soda. And so for our last experiment, it is entitled Copper Sulfate and Sodium Hydroxide Reaction. And so we have copper sulfate as CuSO4 combined with the sodium hydroxide, which is NaOH, will yield to copper hydroxide or CuOH2 combined with the sodium sulfate, which is the Na2SO4. And so with that, we can say that it is a double displacement reaction. And for the evidences of this reaction, we could see in our experiment that there is a formation of precipitate. That after combining the copper sulfate and the sodium hydroxide, there was a jelly-like formation inside our test tube. Alright, so and that is the evidence of chemical reaction for the copper sulfate and sodium hydroxide reaction. Alright, so for our activity for today, you are to identify what are the evidences for chemical reaction for the following setups that I'm going to prepare. Are you ready? Alright, so for our first setup, we will be combining copper chloride with aluminum foil in an Erlenmeyer flask. Let's go! And so that concludes our lesson for today. I hope you learned a lot. Do not forget to hit the share, like, and subscribe button. And tune in next week for more of our video lessons here in Grade 10 Science. So this is Ms. Rox, your Grade 10 Science teacher, only here at Science Matters, where learning never stops.